All right, welcome everyone. So last week we were talking about wiring connections and doing proper splices and repairs and talking a little bit about some communicating voltages, especially the differences between stranded wire and solid wire. So as we continue talking about some good installation procedures and especially electrical procedures, one topic I wanted to cover real well is surge protection and surge protectors. So we have quite a bit of shift of equipment in our industry. We've been using legacy style wiring and we've been using traditional single stage and two stage outdoor units for a long time, but we're starting to move into more advanced pieces of equipment. We're starting to move into inverter technology. And so with inverter technology comes a lot more control boards, a lot more sophisticated controls. And as well, we are now using ECM condenser fan motors, ECM evaporator motors. So we have a lot more controls that are involved with the operation of our equipment. And anyone who is aware of circuit boards will understand that they are prone to electrical conditions. And so as we start thinking about ways to properly protect our equipment, we need to understand what options we have and what those options are actually doing for us. So in the world of surge protectors, we just need to be able to take a peek at what they're doing for us. So Wikipedia says that a surge protector is an appliance or device that's intended to protect electrical devices from voltage spikes in AC current. And that's what we work with is AC current. And a voltage spike is a transient event and typically lasts between 1 and 30 microseconds. It's a very short shift of electrical current. And sometimes it's over 1,000 volts, especially on these 230-volt systems that we see. And when we talk about the lightning aspect, now we're talking about 100,000 volts of electricity, right? So those high voltage surges, as they come through our electrical systems, through our conduits and through our conductors, that's where we introduce them into our electrical circuits that typically are not designed for those types of voltages. So we use a lot of leadless surge protectors on our home equipment inside. We protect all of our expensive televisions and computers and products that have circuit boards. Now we have to start thinking about those type of devices for our HVAC equipment as well, because we're doing the same thing. We're trying to protect our expensive electronics from high voltage spikes. So how we do that, and this is all surge protectors. All surge protectors use a component. It's typically called an MOV, which is a metal oxide varistor. And what it is a variable resistor. So it is a resistor that has potential resistance, but typically doesn't change until it hits certain voltages. So they're used to control or to compensate different elements of the circuit. And when they're used as a protection device, they shunt the current created by these excessive voltages away from the sensitive components. So in the circuit, when we look at how it is installed into the electrical circuit, you'll see, let me grab my Sharpie here. You'll see that we typically have some type of a fuse or a breaker in our system. So we have our main power that is coming in, and then we have our components. So let's just say this was a outdoor unit. This was a condensing unit. But it's an inverter outdoor unit, so it's got circuit boards on it. Well, typically we're going to have fuse or we're going to have breaker in our line, and what we do with the varistor is that we actually bring that between our lines, and then we will direct current away from that actual appliance. So it's in the circuit, and it's typically in the circuit as a parallel component. And it doesn't use its resistance under normal operating conditions. What happens is when it sees a high amount of heat, really, a high amount of voltage, it generates heat and it changes the resistance of the varistor so that it can redirect the current. So that's all it's doing is it's creating a new path of least resistance back to neutral or back to ground, depends on how the circuit is wired. And actually looking at this one, that says AC. That would have actually been a 120 system, so it would have had a hot and a neutral. So it was bringing it from hot to neutral, and it's just bringing all that current back, and it's going to land it back on neutral, or it's going to land it back on ground. Lands it back on neutral, it's going to pop our breaker for us. Lands it back on ground, it's just going to get it out of our path. So they're used as a resistor, but it is only a resistor when it needs to be, which makes it an interesting piece of components. I'm sure, Paul, you know a lot about electrical components and how they work, and transistors and capacitors and how they flow in electrical circuits. It's all about flowing electrons. Anytime we talk about electricity, we are simply talking about the plumbing that we give for those electrons. So we can use things like these variable resistors that are in the circuit, but they're not being used until they're needed. So once that high voltage spike happens, that high heat happens on the electrical circuit, we now change the composition, we change the molecular pull on the components inside of that varistor, and then it allows it to now flow current in that direction. So we're basically creating a bypass around our piece of equipment. So it's in the circuit, but it doesn't do any work until it's overloaded. So if we look at this particular one, this would be more like our one going to an outdoor unit. We can actually stage these and have multiple surge protectors, multiple MOVs. So in this particular situation, we've got a MOV going between line 1 and line 2. We got an MOV going between line 1 and ground or earth, and then we have one between 3 and earth, so that we have multiple paths. So wherever that high current surge is happening, we can direct it, because we can also use these in this type of a scenario. We can also use this to control small spikes in voltage. So if we see that we have an elevated voltage coming across our AC line, either 1 or 2, we can redirect some of that voltage back down to earth or back down to ground and get it out of our circuit so that we can actually control voltage. So then if we add some capacitors into that thing, now we can control over voltages and under voltages by having an additional supply when it goes under. So we can use these circuits not just for surge protection alone, but we can use these for controlling our total supply of power. We can use these to help modulate our incoming voltage. We can control the peak and we control the valley, and we can make it a more neutral platform for our voltage. So we're actually using these as voltage conditioners as well. So it's a dual part device, and it has a lot of opportunities for our equipment, because when we look at the benefit of a steady voltage going into a circuit, well, we don't always have the most steady power supply coming from our lines, do we? So just as a quick poll, I wanted to make a poll here. As a contractor, do you currently offer surge protectors? Let me open up my polls here real quick. Does anyone offer surge protectors for either your outdoor units or your indoor units while you're doing installations? I know you, Paul, you brought this up before, using surge protectors, especially for indoor units, air handlers and furnaces. Randy says, yes, he does. Oh, that's fantastic. That's the things that I want to hear, is that people are actually starting to offer surge protection.
Yeah, especially on mini splits. So at the beginning, that picture you had, the ICM 493, I actually have 2 of those in my house for each outdoor unit, because
Really?
yeah, because the inverters are so sensitive. Most boards, most board failures I see are voltage issues. So.
They are, absolutely. It's funny that you say that, because that's actually where I was heading to. That is my favorite surge protector on the market, is the ICM 493. So that ICM 493 adds a variety of things to it. So it adds the surge protection, it adds the voltage conditioning, and now it's actually going to offer an isolated contactor for that power source. So not only is it protecting the equipment, it can completely isolate the piece of equipment in those conditions. And it just does a really good job of doing that. And it's a simple installation. So you have power coming in that is feeding to the control system. You got power that's feeding out off from our contactor. And so now we can condition the voltage with our board, and then we can drop out the component completely. So that's good to know, Paul, that that we're seeing those, because that's exactly what I use on my inverter systems. So this is one system that I did in the field for one of our contractors. This was a multi-head, a multi-split system that they were having control board failure issues with. and they didn't have control board failure issues with this particular piece of equipment until a new building was constructed just down the road, just about a half a block. And when they did, they put an entire new circuit of transformers. And so they were having very irregular voltage spikes off from the system and just literally smoking the boards on this thing. So we added in a ICM 493 to monitor that voltage, and haven't heard from them in a year. That's a significant difference.
Yeah.
This is our own system, our training center over here at Indianapolis. These are my two Daikin Fit systems, the AC on the left, the heat pump on the right. And so we installed those ICM 493s to protect those as well, because we're in a commercial area, and so our power tends to be a little hot in that commercial area. So this gives me the opportunity to condition that voltage and bring that voltage down, because a lot of our inverter equipment actually has voltage ranges. And those voltage ranges are not as wide as you would think that they were. A lot of them will be from like 208 to 250. And above that, they will actually start shutting themselves down. So I've seen inverter outdoor units that will shut themselves off on internal protection once they hit that 250, 253 volts. So having a conditioning unit on those inverters will get us out of those situations. I was also at one installation way out in the country in southern Indiana, and it was at the very end of a power grid, and they were running like 186 volts on the system. And so the inverter was regularly shutting its down on an internal protection.
Yeah.
So after using a power conditioning device on it, never heard from them again as well. So it was interesting that even at that low of voltage, that it had the ability for the capacitors to store enough and to help bring those peaks and valleys. Because remember, when we talk about AC current, AC is on a wide range. We have our sine wave going up and down, and so it has the potential for higher voltages in those peaks. And so if we have the ability to use like capacitors to grab some of those extra electrons that's on those peaks on our sine wave, we can actually bump that voltage up a little bit. And that's what we're doing with our conditioners. We're actually leveling out that voltage and trying to get it a little bit more regular. So a lot of really good things that you can do with a surge protector and line voltage monitor. So that's the ICM 493. We know it as the B19304. Just superb piece of equipment. It's got an FLA rating of 40 amps, locked rotor at 240, and it has the input capabilities from 180 up to 264. The one thing that I will say about some of these controls is electronics are temperature sensitive, and a lot of times our screens are temperature sensitive as well. So if you notice, the LCD operating range on that 493 is actually -4. So if you're out here servicing a heat pump in the middle of winter and it's below -4, you may not get a readout on the screen, because that actually will read the current voltage situation that you have and any kind of faults as well. So neat little piece. We also carry some smaller, oh, go ahead, Paul.
I think that one's got 5 MOVs in it too.
It does. It has 5 MOVs, and you can actually select those if you need to change from 5 into a lower amount of them. So if you happen to have, fault situations, you can actually adjust those a little bit. So yeah, there are 5 MOVs in that thing.
I also like that most manufacturers have a 10% voltage variance.
Yeah.
So if you have 240 volt coming in, it can have a 10% above or below allowance on the boards. But that one, you can actually dial it in.
You can tune it in.
Smaller amount. Yeah. So I actually have mine set at a 5% tolerance, my actual ICM, so that my boards never have to go into their fail safe, just to
Exactly.
extra insurance.
And that's adjustable for under and over between 5 and 10%.
Yeah.
So a lot of flexibility and adjustability with that control. That's the reason for me, it's the best piece of equipment that I've encountered yet. ICM had sent me a couple of those before they actually came into the Johnstone selection, and I thought, wow, it's an interesting piece of equipment. And then we dove into it. It's like, wow, that's actually got a lot of practicality. So it's quickly becoming our most popular surge protection device. Now, there's a lot of different surge protectors out there that still have high voltage capabilities. So there's also that ICM 517. So that one's still got 100,000 maximum amp control to it. It's rated at 120 or 240. So it's just a more compact unit. We sell a lot of these for air handlers and for furnaces. So it's a simple add-on component. And it's rated up to 60 amps. There's also the Intermatic Compressor Defender. I think Bob Vila sponsors that one. So that's a real popular one that's out there. It's rated for 120, 208, 240. It's rated 100,000 also. So nice little add-on component. We've got the Linebacker, which the downfall with that one that I've seen is it's a 10,000 rating, but it's still a good little piece. That's the Supco LBK10. So that one's been around for a little while and become a pretty popular surge protector. It's a 120, 208, 240 as well. We have the Zebra, and the nice thing about Zebra is they have units that are for, I would consider, smaller capacities. So they've got on the little Zap Pro, that's one that can be added for outdoor units for, you know, AC and heat pumps, just to help protect the control board itself. But then we've also got along that lines, this is a surge protector that's designed to protect ECM motors specifically. So the 5-pin power connector that is coming into that module on the back of your ECM blower motor, this is designed as a plug-and-play surge protector for that. And I highly encourage these on ECM motors. They do not come from the OEM manufacturers with this surge protector. They do have a overload built into the module itself, but if you lose that, you lose the whole module, versus adding on this small surge protector before it to save the entire device. Much rather lose one of these than lose an entire module. So if you've not looked into the VZ Pro, you really should, especially if you have situations that are on lines that are having excessive voltages or having brownout scenarios and you're burning up ECM motor modules. Here's the device that you need to have on that circuit.
When I was in the field, we installed those at install at a new equipment. On a new piece of equipment. We would install it, especially when it was rural and in the country, or if the house had a whole house standby generator.
For sure. That'd be a great place for one, because when that generator fires up, I guarantee you're going to have some voltage changes. And so great little piece for the money too. They're not a super expensive, and it is that standard 5-pin. It's good for the 120 or 240 systems. So to work on gas furnaces or air handlers, either one. So we've got the Intermatic Ag 3000, which is a real common surge protector. And that one's also got the MCOV control to it at 100,000 amps, 120 or 240. So pretty significant piece of equipment. The nice thing about that one is it actually offers a 3-year, $7,500 connected equipment warranty along with it. So you're adding a little bit of extra protection, and it's a great selling feature to add additional warranty or additional, coverage, insurance for that installation that you're doing. We also sell some whole home surge protectors. So Eaton has a variety of surge protectors that are designed for whole house applications. So you can use this at your service panel and give complete protection to your entire system. They also have a line of cable and telephone surge protection as well. So you can put in surge protection devices for all of your incoming utilities. One topic that I wanted us to cover a little bit while we are here, surge protectors are becoming more popular, and we have had some failures of surge protectors out in the industry. It's been a little while. So I just wanted people to be aware of surge protectors that we have had incidences of failures with. Supco is a fantastic parts and small equipment supplier, and we sell a lot of their products, and I use a lot of their products. And there was a small line of units that was produced early into the use of surge protectors. It was the SCM 60, SCM 150, and then the co-counterpart was just a same unit, just a different brand, was the SICOM SYC 120-240 T2. And we had some incidents with the cases on these leaking. So it wasn't that the component itself had failure issues. It was that the company that built the shell for it didn't seal very well, and they were able to get moisture inside of those. So Supco had actually released a warning about that they were having failures with those, and that up until July, I think it was July of 2019, they were, March of July 1st of 2019, they were replacing those and upgrading those free to that LBK10 that I showed you a while back. So the LBK10 is the replacement for all these. So if you encounter those surge protectors in the field, be aware that they are prone to some failure and they have caused some structural fires in the past. So if you see those 3 surge protectors in the field, highly recommend that you remove or upgrade into a different surge protector. So just a little thing to be aware of. So there was a surge protector on that one. It completely roasted it. That one got hot enough to melt some vinyl, and these were all from that same surge protector. So there are some out there that have had some failure issues, but they were addressed quickly and they were taken out of service and replaced with that LBK10. But if you run into any of those 3, just make your homeowner aware that there have been some issues in the past and that we're there for preventative maintenance. So preventing failures is what we're there for. So good time to upgrade into an LBK10 or any of the other surge protectors that are on the market. And my preference, that ICM 493. So any questions on surge protectors? Thank you all for joining us, and we'll see you the next time on FlexTrain.
See you.